This screencast is going to discuss how to solve the very last problem in notes for empirical and molecular formulas, number 19. Number 19 is asking you to determine the empirical and molecular formulas for caffeine if the substance is composed of all of these and it has a molar mass of 194.2. So we're actually solving two things here. I'll start first with the empirical formula. So normally in that poem, we were supposed to take that percent and convert it to mass. But because we are already given mass, I'm going to go ahead and just write down the given. So 49.48 grams of carbon, a little multiplication sign, leave a little space to do hydrogen, then also with nitrogen, and then with oxygen. So I kind of did my first step already. So this is my star step. I converted all my, well, I didn't have to convert. I have all my masses now. Now, the next step is to take all those masses and convert them to moles. So if I take my carbon, the way that I convert it to mole is I need to use molar mass. Right? So molar mass of carbon, 12.01. I'm going to do for every 1 mole of carbon is equal to 12.01 grams. And I'm going to do the same thing for hydrogen and the same thing for nitrogen. Okay, so for nitrogen, that is 14.01. And then for oxygen is 16. So right now, I just did step 2. I converted mass to mole. And then I would have to punch this in the calculator, and then I'm not going to round yet. Okay, so if I'm not rounding, I'll leave like maybe 5 digits or so after the decimal place. I get 4.1199 for carbon. For hydrogen, I get 5.099. For nitrogen, I get 2.0606. And then for oxygen, I get 1.030625. And all of these are in moles. So this is moles of carbon, this is moles of hydrogen, this is moles of nitrogen, moles of oxygen. For my third step, I want to divide all of my moles by the smallest number of moles. So looking at all of these, the smallest number of moles is oxygen, 1.03. So I'm going to divide all of them. So right now I'm doing the third step. Divide all of them by the same number. And the reason for that was because we wanted our numbers to be a little bit easier to work with. So if we divide the smallest number by the smallest number, we get a value of 1 mole right here. And then we'll just compare later for our other steps to see if we have to do anything else extra. Okay, so once I do this, punch this in my calculator, and here it says you can round, but only if it's a really close like to the next number. So I get 3.997 here, which is so close to 4. For this one, I get 4.996, which is so close to 5. For nitrogen, I get 1.999, which is so close to 2. So this one now is saying I have 4 moles of carbon for every 5 moles of hydrogen, for every 2 moles of nitrogen, for every 1 mole of oxygen. So here we're actually done. We can figure out our empirical formula. So our empirical formula, I'll write it up here. Empirical formula would be C4H5N2O1, meaning we don't write the one. We don't write the 1. And then that would be my final answer. And if I wanted to double check, I could just Google the formula for, oh no, I can't Google that one because that's the empirical formula. Never mind. Okay, so we could also work backwards and you could see if the percentage would be like matching up all of these if you assume you have 100 grams. For the second question, now the second question is asking you to calculate the molecular formula. Okay, so for molecular formula, you would, oh, I guess I should mention, I didn't have to do step 4. I didn't have to do step 4. I didn't have to multiply it to a whole because all of these were whole numbers. So for the molecular formula, the way that we did that is we took the molar mass of the molecular formula divided by the molar mass of the empirical formula to see how many times heavier it is. So the molar mass of the molecular formula is given. It's the 194.2 grams per mole. The molar mass of empirical formula we would have to calculate. So this empirical formula is from above there. So it's the C4H5N2O. So I'd have to do on my calculator 4 times 12.01 plus 5 times 1.01 plus 2 times 14.01 plus 16. And if you do that, you should get 97.11. And then once you do that, you get 1.99, which is so close to 2. So this is saying that your molar mass of your molecular formula is 2 times heavier. As it's 2 times heavier than this one. So I would do 2 times all of your subscripts. And then for my molecular formula would be C8H10N4O2. And this is the one that you can Google. So if you just Google molecular formula for caffeine, it would be this. Thank you.